Hello everyone. In the last class I was telling you about the occurrence of igneous rocks and I was telling you about what do you mean by igneous rocks. So in this class I am going to explain the classification of igneous rocks. Classification of igneous rocks. See, in this classification of igneous rocks, we all know that which is the dominant element which is present in the earth crust. The silica is the dominant element which is present in the earth crust. But I was telling you in the earlier classes, that was in the mineral section, which is the dominant element which has been present entire earth, that is iron. Okay, this igneous rocks has been classified based on the percentage of silica. Okay, silica is an element. Based on the percentage of silica, the classification of igneous rocks has been formed. In this classification, igneous rocks has been classified into 4 categories. Which is that 4 categories? One is felsic, intermediate, mafic and ultra mafic. These are the 4. What do you mean by felsic? See what I am doing? This is the category which is with respect to the percentage of silica. Okay, felsic means feldspar and silica. Feldspar is a mineral and silica is a mineral. Then what do you mean by mafic? Mafic means magnesium and iron, ferrous. Magnesium and ferrous, that is iron. Okay. See, in this table I am going to write what is the percentage of silica in felsic. This is greater than 65%. The percentage of silica in felsic is greater than 65%. In the intermediate, it is of 55 to 65% of silica is present in the intermediate rocks. Similarly, in the mafic, the percentage is 45 to 65%, which is being present. In the ultra mafic, the percentage of silica is lesser than 45%. This is the percentage of silica which is being present in the igneous rocks based on the classification. What do you mean by felsic? Feldspar and silica. What do you mean by mafic? Magnesium and iron. Okay. And let us see which are the other elements. Present in felsic. The other element which has been present in the felsic is aluminium, potassium and sodium. Aluminium, potassium and sodium. Then what is the elements which has been present? Aluminium, calcium, sodium and iron. We can able to see the absence of potassium here. The addition of calcium and iron. Next, what in the mafic? Aluminium, calcium, magnesium and iron. Again, the absence of sodium. Next, what are the other elements which has been present? I am writing magnesium, iron, aluminium and calcium. We can easily see the dominant of magnesium and aluminium in the ultramafic rocks. Means what it tells, the felsic rock, apart from silica, aluminium is dominant. Potassium would be present. In the intermediate rock, aluminium and calcium. When it comes to mafic, again, there is no presence of sodium or potassium. When in the mafic rock, we can able to see magnesium and iron. When in the form of ultramafic rock, automatically magnesium and iron. See, whichever the rocks we used to see, the dark in color means the presence of the iron or the magnesium. In the further classes, I am going to explain you. That is, we call it as the ultramafic rock. Okay. Next one is, what is the viscosity? Viscosity which is been present in the felsic. It is, viscosity is very high. Viscosity is very high. Here it is very medium, it is low, and it is very low. I was explaining the magma chamber, which has been consist of acidic and basic. It is in a liquidous in nature, and automatically the viscosity would be high in felsic, whereas very low in ultramafic. Why it is very low in ultramafic? Because due to the other components which has been presence of magnesium and iron. Okay. Next, what is the temperature? What is the temperature to solidify? To solidify. What I was explaining, the temperature would be of 900 degrees Celsius to 1800 degrees Celsius. This is magma chamber. Magma chamber. But here the temperature tends to cool. The felsic is 600 degrees Celsius to 800 degrees Celsius. Similarly, in the intermediate, 800 degrees Celsius to 1000 degrees Celsius. In mafic, 1000 degrees Celsius to 1200 degrees Celsius. Similarly, ultramafic, that is greater than 1200 degrees Celsius to probably up to 1600 degrees Celsius. These are the temperature which is required to solidify. Which is the mineral examples? Which is the mineral examples? Sorry, rock examples. Rock examples. Okay. The felsic is nothing but granite. Which is the best example for felsic? Granite. Next, which is the for intermediate diorite. For mafic, gabbro. For ultramafic, peridotite. See, these are the mineral examples for intrusive rocks. Similarly, the same temperature when it is being squeezes out, what would be the examples? See, this is comatite. Comatite is a rock. When the same rock which is being present beneath the earth to form the same chemistry or the same composition, that is called peridotite, it is an intrusive rocks. When the same elements which is squeezes out through the volcanic vent, that is the rock name which is being called as comatite. Similarly, the same composition which is being formed beneath the earth's surface, we call it as gabbro. The same composition, if it comes out from the volcanic rock, then it is called as basalt. It is being called as basalt. If the diorite, that is the intermediate, the composition, the temperature would be of 800 to 1000 degrees Celsius. The formation is diorite. When it is comes out, then it is called as andesite. Andesite is a rock. Similarly, the same temperature which is being coming out, that is being called as rhyolite. See, this purple color, that is granite, diorite, gabbro or peridotite, that is a intrusive rocks. The rock which tends to cool beneath the surface we call it as the intrusive rocks, that is the varieties granite, diorite, gabbro, peridotite. The same composition which is coming out from the magma chamber squeezes out in the volcano through the volcanoes to form an extrusive rocks, that is called rhyolite, andesite, basalt, comatite. So finally, what I like to conclude, the igneous rocks has been classified based on the percentage of silica. We all know that the percentage of silica is the dominant element present in the earth crust. See, the light color, usually when we are going to see the rocks, if it is a light color, then we call it as the based on the percentage of silica. Again, the classification is of 4 types, which is that felsic, intermediate, mafic and ultramafic. The percentage of silica is 65%, it might be 55 to 65, 45 to 65, lesser than 45%. What are the other elements? We can be able to see aluminium, potassium and sodium. In the intermediate, the potassium is absent. Similarly, in the mafic, the sodium is absent. When we are going to see in the ultramafic, the dominant of magnesium and iron compared to the silica. So the viscosity means, because the magma chamber is completely made up of liquidus, that is acidic or basic, the viscosity in the felsic is higher and the viscosity of ultramafic is lower. Usually the temperature 900 to 1000 degrees Celsius in the magma chamber. When it solidifies, it requires minimum of 600 to 800 degrees Celsius, maximum of 1200 degrees Celsius. These are the rock examples. So the percentage of silica has been classified mainly based on the percentage of silica. Thank you.